হ্যাঁ, বলো। আচ্ছা, ঠিক আছে, আমি ইউটিউবটা খুলেই রেখেছি, এটাতে সাউন্ডটা বাড়িয়ে দিই। আসছে, সাউন্ড আসছে। হ্যাঁ, হ্যাঁ। বলরাম, বলছি যে আমার এখানে একটা প্রেজেন্ট নামটা এনাবেলড হয়ে রয়েছে, ওটাকে অফ করা যাচ্ছে না কেন গো? আমি বেরিয়ে যাবো, একবার বেরিয়ে গিয়ে ঢুকবো। প্রেজেন্ট নাও, ওটা এনাবেল হয়ে রয়েছে, মানে একটা চাপ হয়ে গিয়ে ডিসেবল টাইপের হয়ে রয়েছে। যাচ্ছে না, করা যাচ্ছে না। হুম। হুম, বলছি, বলো। হ্যাঁ, হ্যাঁ। হুম। ঠিক আছে, আমি সাউন্ড অফ করে যাবো আমার।
হ্যাঁ বলুন।
আমি ইউটিউব লিংকটা শেয়ার করছি।
Good afternoon, sir. Good afternoon, Balramda. Um, Good afternoon, everyone. I, Shudipta Roy, Assistant Professor on behalf of Department of Information Technology, welcomes you all in today's session. Honorable Principal Ma'am, Professor Dr. Sutopa Mukherjee Ma'am, Honorable former Dean Academic Dr. B.N. Chatterjee Sir, Honorable Professor Deepankar Sarkar Sir, Honorable HOD of IT Dr. Shabnam Sengupta Ma'am, respected faculty members, and dear students. It gives me an immense pleasure in welcoming all of you to the third day of our workshop RTIC 2020. Today we will have our first session on integrated building management system by Dr. Priyobroto Adhikari sir, and then we will have hands-on session on IoT by Mr. Oshim Panda sir. So it is a great honor for me to introduce and welcome our speaker, Dr. Priyobroto Adhikari. Dr. Adhikari is presently working as professor in mechanical department at New Horizon College of Engineering at Bangalore. With a total experience of 16 plus years, he has served HVAC industry such as Blue Star, Carrier AC, SEC LLC in Oman, ETA Engineering PET Limited, RTIC India Limited for 8 plus years in various capacities in India and abroad. His last industry assignment was Zonal Manager at East RTIC India Limited. He is an ISHRE Life member. Dr. Adhikari has completed his Bachelor of Engineering in Mechanical and Master of Engineering and PhD from Jadavpur University, Kolkata. He has several Best Paper Award in his credit, that is GoWB, NIT, etc. He has total 100 plus publications in various national and international journals, conferences. His area of research include turbo machines, HVAC, renewable energy, GED, etc. He is among the top 10 global researchers in Google Scholar in turbo machines till date. So today we are privileged to have an opportunity to listen to him. Now I would like to request Dr. Adhikari to deliver his lecture and share his screen. Sir, please.
Thank you, madam. Am I audible?
Yes, sir, you are audible.
Yes, sir.
Okay, I'm just sharing the screen.
Yes, sir.
Yes, sir. Yes, sir. এক ঘন্টা বাদে
Um, I think I think he's joining again. I think he's joining again. Yes.
Yeah. Am I audible now?
Ye-
And you can see my screen? My screen is visible?
Yes, sir. Yes, sir. Your screen is visible.
Okay. Thank you.
Thank you. Thank you, sir.
First of all, good afternoon, everybody, one and all present. I am honored to be a speaker in the FDP program of BP Poddar Institute, this faculty development program of Information Technology Department. Now, sorry for the technical glitches in the beginning itself. There are students as well as faculties who are from information technology background. Now, I don't want to go into much more details of mechanical engineering because then the FDP will become very much boring. What I will do as an IT professional or computer science engineer, the bridge you make between the gap between application and other engineering, I will just discuss the application part, and then I will also talk about one of the case studies. Now, integrated building management system, it is basically a software designed by the IT professionals or the computer science engineers, marketed by various multinational companies like Johnson Control, Honeywell, and so on, which is a software that synchronizes all the main equipments of a particular commercial building. Now, what are the equipments? The main equipment is the air conditioning system, or we know it as central plant. Other than that, the safety systems like firefighting systems, pumps, pumping systems. That pump can be the toilet water pump, that can be the firefighting water pump, that can be the sewage water pump, that can be the water pump giving water to the spring in the garden for landscaping. So all these things are synchronized and taken care by one single platform or one single software, which is known as building management system software. And as I told you, companies like Johnson Control, companies like Honeywell, they are having their own software. They are selling those softwares to the building builders or promoters. From this slide, you can understand that the first car in 1914 made by Ford was having only steering and gear. But if you see a car, modern car, it will be having a dashboard, and that dashboard is fully digital, and each and every characteristics of the car is displayed in the dashboard, digital dashboard. So you can understand the difference between the old car and the car now we are using modern cars. Similarly, in case of a building, earlier also we had central plants, but those central plants were manually operated. In present scenario, not only the air conditioning central plant, along with the HVAC system, we also control the firefighting system, the pumping system, and so on with a single platform or a single software, which is known as building management system. And now the stage is proceeding so fast that that building management system has to be operated and maintained from a distant remote place. So we need the importance, we can understand the importance of the IoT, Internet of Things. In building management system, the left top figure, we can understand what all are clubbed. First is the energy meters, second is lighting, third is fire protection, fourth is 24/7 monitoring or security system, public health engineering, PEH, that is the water supply system. So all these things are covered in the building management system software. If we see the history of building management system, it started at around 1980s, and that time it was called as building control. Slowly the things changed, got upgraded, and it is known as building automation in 1990s to 2000, when our sector 5 was just coming into picture, Salt Lake sector 5 buildings. Then 2010 around, the building automation got more upgraded, and it was focusing on the building performance system, green buildings, energy management, all these parameters came into picture. And finally, in today's scenario, we are into smart buildings. Now, what are smart buildings? Smart buildings are the buildings definitely having building control, building automation, building performance. Along with that, it also includes IoT application. You know better than me what is IoT, being information technology students or faculties. I am not going into that detail. So this picture just shows what all things are coming under this IoT platform and can be synchronized together. And right picture, we are showing the various components of the building management system, which is synchronized in building management system software, and finally it can be controlled through Internet of Things. Now coming, as I started with traditional BMS, and in today's scenario, present scenario, the IoT BMS. Now, is it an open system, traditional BMS? No, you cannot control it from outside the building. IoT BMS, yes, you can control, you can see, you can check, you can change the parameters or the settings from anywhere. Second is whether it is very high cost BMS, yes. But IoT BMS, compared to BMS, if it is already fitted, IoT BMS is not a costly one. High cost per point, BMS is yes, because every time you have to travel to that particular place, you have to operate from there only. But IoT BMS, you can operate from anywhere. So you can see various parameters where we can get that IoT BMS is more customer or consumer friendly rather than the traditional old BMS system. Just let us take a small school, smart school building management with IoT. Nowadays, faculties as well as students must be knowing that even the school bus, the parents can track where the school bus is presently. Similarly, all the parameters like fire alarm, access control, surveillance, CCTV camera, ventilation fan, water supply system, whether water is there in the drinking water tank, whether water is there in the overhead roof tank for toilet, whether water is there for the flush tank. So all these parameters, whether they are operating as per the set point, we can get in front of the desktop or a laptop. So this is what we mean by the smart school building management IoT system. It is just an example to get an idea what is building management system and how it operates, and your topic IoT that will be controlling from a distance place. I think I am audible and visible. Hello.
Yes, sir, you are audible.
Okay. Now, as I told you that a big part of the BMS system, building management system, is controlling of the air conditioning system or HVAC system. What is HVAC? Heating, ventilation, and air conditioning system. Don't confuse with high voltage alternating current. It is HVAC means heating, ventilation, air conditioning system. Heating we don't generally need in our buildings because Kolkata is already hot and humid. But in some industry applications, they also need heating. Mainly for industry, we need ventilation where proper air oxygen supply has to be maintained, and air conditioning to provide a comfortable atmosphere for human being. Dear all, dear participants, you keep in mind the most comfortable, optimum comfortable temperature and humidity is 24 degrees centigrade and 50% relative humidity in the air. If we can maintain 24 degrees centigrade temperature in a room with a 50% RH, then that workplace or that room will be most comfortable for a human being to work or stay. Now, what are the loads that are not allowing to maintain 24 degrees centigrade? The loads are divided in two parts. One is latent load, one is sensible load. Again, the sensible and latent load, they are also divided in two parts. One is inside and outside. So coming to outside first, outside sensible load, that means which will rise the temperature, are the sun heat or solar heat in any form. It can be radiation, it can be conduction, it can be convection. Radiation, if sunlight is dropping on a sofa or a bed, after some time that will become hot. Convection, the air near to the window will start getting hot and come inside, and again cold air will go near the window. Conduction, the window aluminum frames will become hot and they will dissipate heat inside the room. So solar is the outside sensible heat source. Fresh air carrying moisture which is coming over the ponds, rivers, are the source of outdoor latent heat. Whenever there is moisture, we will call it a latent heat. Similarly, in the room, within the room, there are both latent and sensible heat sources. In one word, all the electrical equipments, light, fan, PC, mobile, printer, scanner, everything is sensible inside load generator. and the item which is adding moisture to the air inside the room will be latent load generator. So who will add moisture? Human being who is sweating. He can add moisture to the room. If you have a coffee machine or a electric kettle, that can add moisture to the room. So we can understand that all the sensible inside load generators are electrical equipments, but all the latent inside load generators are not electrical or maybe electrical, as electric kettle and coffee machine, as well as human being. And the most critical part is the latent heat generator also adds some sensible heat inside the room due to body temperature. So I hope we understood how the temperature inside a room increases from 24 degree to 30 degree, 35 degree, and make the room uncomfortable for staying or working. Now there where comes the importance of air conditioning system to maintain it at 24 degrees centigrade and 50% RH so that the person can work or stay comfortably. And in commercial buildings, this air conditioning system will be controlled through the building management system, and in turn the building management system itself will be controlled by IoT. These are the main 5 cycles of air conditioning central plant. I am not going into detail because it is not very much directly related to you, but all individual, there are 5 cycles. All these cycles are connected to the building management system and they can be controlled by IoT. Now we have a big question. Why air conditioner? If we take a example of an adult human being, roughly he will consume 1 kg of food per day. He will consume 2.5 liters plus water per day. Whereas the same person will take 12,000 to 15,000 liters of air per day by breathing. I hope you can understand the importance of breathing fresh air now, and that too in COVID scenario. I again repeat, 1 kg food, 2.5 liters of water, whereas 12,000 to 15,000 liter of air per day he is taking in and out by the breathing process. So that is where the importance of good air, fresh air is important from the air conditioning point of view. In this COVID scenario, I thought I will put 2-3 few slides so that you all understand how to handle coronavirus or other bacteria viruses with the help of air conditioning system, because most of the commercial places, colleges, hotels, hospitals, shopping malls, everywhere it is central plant. So whenever you are going to a doctor with a hand pain, the first doctor will tell you to go and do some blood tests as well as X-ray. And seeing the X-ray report, the blood report, they will suggest you medicine. Why? Because they want to know the root cause of the problem. Similarly, if we try to handle the coronavirus or COVID scenario, we have to understand through which path this particular virus gets transmitted to human being. And in this particular COVID scenario, building management system linked with IoT plays a very important role. I'll come to that. So from this flow diagram, you can understand that all the SARS and COVID viruses comes through the rodents or bats, then transmitted to mammals, and finally to human being. Coming to the size of the coronavirus, you can understand that if we take a sample human hair, if we take a sample of a human hair, the various part of the human hair size is shown in the figure. The coronavirus is still smaller than this human hair thickness. PM10 particle size, PM2.5 particle size, PM1 particle size, whereas coronavirus size is 0.1 micron. From let's second one, coronavirus is 0.1 micron. Even now, you can see the red blood cell here, 7 micron. So it is red blood cell is bigger than the coronavirus size. Now, how to handle this coronavirus? First, you can eliminate the source. That means complete lockdown. We are not going to any place. We are not moving to coronavirus places. Substitution. If you detect a place that is having coronavirus, you can replace the hazardous area. Hotels are closed. Now the third step comes engineering control, where all the engineers are involved. Engineering control involves ventilation, filtration, indoor environment control, and physical barriers. My dear participants, in this ventilation and filtration system, there will be filters, and those filters will be controlled, will be analyzed by the use of building management system, and the building manager, with the help of IoT device, can see from any place whether the filter is clogged, whether the filter needs to be cleaned, and whether the filter needs to be changed. And there lies the importance of BMS as well as IoT. Administrative control, work from home, staggered schedule, social distancing, and finally, personal protective equipment for all, as we are all using masks, using hand sanitizers. So this is the hierarchy of control of bacteria and virus. So the yellow portion is the engineering control through which we can avoid not only corona but any virus and bacteria, and we can offer a better world. So there lies the importance of IoT and BMS. Just a bit about coronavirus transmission. The large cough droplets fall on nearby surfaces and objects such as desks and tablets, laptops. People can get infected by touching those contaminated surfaces and then touch their eyes, nose, and mouth. Here is a graph showing sneezing is more dangerous than coughing, and finally even talking can also transmit the virus. One more important thing we are not focusing on, the fecal transmission of infection is recognized by WHO. Flushing toilets creates plumes in the air containing droplets and droplet residue when toilets are flushed with open leads. Dear participants, you can think, sir, how it is related to our IoT? My dear students, my dear participants, please understand there is an exhaust fan which is running with the help of BMS, and whether it is running or not, you can control and analyze with the help of IoT. So there lies the importance of exhaust fan connected to BMS and connected to IoT. The building management system will track it and inform the building manager maybe who is not at Salt Lake and sitting at Gariahat, that sir, this exhaust fan is not properly working and the place is not safe anymore. So what is the solution? What we need to do to handle coronavirus kind of situation or any other bacteria or virus situation with the help of BMS and IoT? As I already told, ventilation and filtration provided by heating, ventilating and air conditioning system can reduce the airborne concentration of SARS virus, thus the risk of transmission through the air. So we have to continuously take help of IoT as well as BMS system. Why I am telling IoT? Because after 6 o'clock, the building manager, his duty will be over. He will be going to home. But in this scenario, we cannot sleep well. We have to continuously monitor, we have to continuously check whether the building system is running properly. So with this IoT system, the building manager sitting at home can check whether all the ventilation and air conditioning is proper to the along with IoT. Coming to relative humidity, just for your understanding, the relative humidity level of 40% to 70% is considered to be the most suitable environment for human and decrease problems of pathogen. Sir, how it is related to information science? My dear student, today you are working in Kolkata. Tomorrow you will be going to some European countries. In winter, you know that we have lip crack problem. And why the lips cracks? Because of low humidity. Similarly, why you are sweating in Kolkata? Because of high humidity. So you can understand 40 to 70% humidity is very good atmosphere to stay away from the pathogens, that is bacteria and viruses. So whether your air conditioning space is maintained at 40 to 70% RH, there is humidity stat which will check and inform you through BMS and to IoT. If the relative humidity comes down, you have more humidity, then you have to lower the humidity with the use of dehumidifier. Now what is humidifier and what is dehumidifier? I'm not going into that detail because it is a mechanical related thing, but as IoT engineer you should know that the relative humidity 40 or higher than 70, and it will be informed through the BMS system and will be controlled through IoT system. There lies the importance. Similarly, for temperature, the temperature tends to be a factor that directly affects the comfort of the building or hospital occupants. Comfort temperature is generally considered between 24 degree to 30 degrees centigrade after accounting for air velocity, relative humidity and clothing. In the beginning itself, I told that 24 degrees centigrade is comfortable temperature for human being. By God's grace, 24 to 30 degrees centigrade, the pathogens are also not affecting the human body. So in a nutshell, we can tell that if we maintain 24 degrees centigrade and 50% RH with the help of air conditioning system with a proper filter, we are safe in this COVID scenario. I repeat again, if we maintain 24 degrees centigrade and 50% RH with proper filter, which will check the pathogens of the scenario. And who is going to check? Our BMS and IoT system will inform us whether the temperature, relative humidity, as well as the filter is functioning properly. Ma'am, I'm audible and visible. Can I proceed? Hello.
Yes, sir.
Yes, sir.
Okay, thank you. As I have told you regarding the little bit of air conditioning system and how it works, now let us come to our topic. What is digitalization? How building technology is implemented? Basically, there will be a intelligent structure as shown in the. There will be services, consultants, data-driven intelligence. Nowadays, artificial intelligence is also coming into the picture. Sir, what is the example? You can ask intelligence. If you have 5 years, 10 years data, and you for this, we are getting so much of electric bill. Now, from that data, you can find out if we replace the all 40-watt tube lights by 10-watt LED lights, what is the initial investment vis-a-vis what is the electric bill running cost? So there lies the importance of advanced data analytics, integrated building management system, and controls. And finally, with the help of this intelligent infrastructure, the customer feels more safe and the system is more reliable. System architecture, the participants are more knowledgeable than me, but still I will just show you the system architecture in a very simple manner. It will have a building management system, which will be supported by system level control, and finally unit level control. Now, all these things are part of intelligence, information, and data. What are the subsystem of IBMS or Integrated Building Management System? Dear participants, wherever I am talking about IBMS, Integrated Building Management System, it by default includes IoT, because Integrated Building Management System is operated with the help of IoT. So IBMS means IoT plus IBMS. So what all comes under this? Energy management system controls the HVAC, I told you, heating, ventilation, and air conditioning system, electrical system, public health engineering, that means the water supply system, lighting controls, BTU metering, energy metering, tenant bills. Now, what is tenant bill? You think of a shopping mall. The shopping mall is having Reebok showroom, is having Titan showroom, is having a multiplex, is having a KFC. So all these companies are tenants. So the tenants are using the AC, cold air. The tenants are using the water. The tenants are using the electricity for their lighting. So all this metering, individual metering can be done with the help of IBMS, and with the help of IoT, the building manager can get all the data from a place where the mall is not there. Maybe the mall is at Salt Lake, let us assume city center 1, and the building manager stays in Gariahat area. So he will have all the data handy with the help of IoT. Electric power monitoring system. Now coming to fire life safety systems, it includes fire detection system, that means smoke sensor, heat sensor, access control system. Whether when you are going to a shopping mall, there will be a car stopper. So when you proceed there, there will be sensor. The car comes, you get a receipt. Automatically the bar goes up and you can proceed for the parking. CCTV, closed circuit TV, it is a part of security system, and perimeter protection systems, which is again a part of CCTV kind. Coming to the architecture, architecture of the building management system includes various parts you can check. Now finally, all the equipments like the BTU meters, I told you all the tenants will having their BTU meters. The DG set, that is the diesel generator set, when the power is not there, all the tenants will be having diesel power. The chiller, that is the air conditioning system, the water meters, STP, sewage treatment plant, WTP, water treatment plant, fire alarm, everything, everything will be synchronized in one platform. And ASHRAE, American Society for Heating, Refrigeration, Air Conditioning Engineers, has given a standard platform known as BACnet. So this BACnet is the main platform for building management system. I can give one very simple example. BACnet is analogous to Windows operating system, and you can use MS Office, which supports Windows. You can use Windows Media Player or some other player you can download like VLC Media Player. Similarly, you can use some Adobe Photoshop, which again supports Windows. But suddenly, if you bring one software which supports Linux, cannot be installed in Windows system. So similarly, if the chiller manufacturer, Carrier, York, Train, all these multinational companies, DG set manufacturer, Caterpillar, Kirloskar, all these DG set manufacturing companies, energy meter companies, transformer companies, if everyone have their individual system and not a common platform like Windows, then it cannot be synchronized in BMS. So all the manufacturers will have the same operating system kind of platform. I am telling this operating system word to make you understand the analogy between BACnet and Windows. So all these softwares like application softwares, VLC Media Player, Photoshop, MS Office, these are different DG set, chillers, all these softwares. So now all these softwares will be on the platform of Windows, which is called BACnet by ASHRAE. And then finally, it will be synchronized with the IoT platform. These are the equipments that comes under HVAC. I'm not going into more detail. Air handling unit, fan coil unit, chillers, pumps, boilers, not in India, VFDs, variable frequency drive. But all these equipments are directly controlled by building management system and IoT. The building manager, with the help of IoT in today's scenario, is controlling everything from a distant place 24/7. Now, how this BMS runs? There is centralized workstation computer. There is DDC controller, that is direct digital controllers, field devices. I am not going into much details because it relates to the electronics and instrumentation engineering. Just for your idea, what is a DDC controller? You can see that it works on SQL Server, BACnet, Ethernet. You know more than me. I'm not going into much detail. Now, what is the benefit of digital controller? Control and monitoring trends, boosting energy efficiency. This is a very important thing. Smart security, very, very important. Easier maintenance. I told you, there will be a red bulb glowing in the IoT app that your filter is clogged and properly air is not getting filtered. That means the room or the space air conditioning is not working properly. So it is a danger zone in COVID scenario. So all these digital informations will be passed on from the equipment to the BMS to the manager through IoT. Now, what does intelligent microprocessor control means? I have just shown a figure from the field device to operational parameters. Everything data will be collected and then data will be shared with the BMS system to the building manager. Building the DDC controller, that is direct digital controllers with input and output device. There are analog devices and digital devices. Analog input AI, digital input mentioned as DI, you can go through, analog output and digital output. And all these input and output, you know, all the participants know as an information science engineer, are required for taking decision and making changes of the system. These are some field DDC controllers at unit level. It includes internal components like processor, memory, input-output slots, power supply, and so on. This is the air handling unit. Why I have shown you? Because you should know where the COVID-19 kind of bacteria and viruses are actually trapped in air conditioning system. You can see top middle air filter. That is the police station. So air filter, if we use proper air filter, the outdoor air or the return air, left side it is written outdoor air, bottom it is written return air. Return air means, see, first you have to understand one thing. Air conditioning system, every time it does not suck outside air, cool and send to the conditioned place. It does not do every time. When you are starting the system, the inside air is being cooled. I am talking about commercial AC, not the bedroom split AC. I am only talking about commercial AC, hotel, hospital, shopping malls, and so on. So when you are starting the system, the air enclosed in the commercial building is 100% air. Now, in first cycle, which is called air change, the full air will be cooled. In the second change, the cooled air, which is taking heat from the shopping mall, kitchens, human beings, will return, named as return air, and that temperature will be 27 degree. The supply air, right bottom, will be 20 degree. That 20 degree air will go in the space and maintain 24 degree as a comfortable, after mixing, as a comfortable place for human being. Slowly, the 24 degree, after taking heat from the KFC kitchen, from human body and all, it will rise to 27 degree and come back as return air. While coming back as return air, it will carry viruses and bacteria. So 90% of the return air we will take back, and 10% of outdoor or fresh air we will mix with the return air. Both are having bacteria and viruses. So again, we have 100% air. First, it will go through air filter. And that air filter plays the crucial role in handling this COVID scenario. Now, where is IoT, sir? You are talking about air filter. My dear student, my dear faculties, my dear participants, if the air filter is clogged means choked, then the air filtration system is not working properly, and the virus and bacteria will be there in the mall for a long time. So who is going to tell you and me that, boss, the air filter is not working? Hello, it's an alert. That is done by the building management system and IoT in turn. Similarly, the cooling coil, if it is not properly cooling, I told you, the risk can be avoided within 24 to 30 centigrade temperature. So whether it is cooling properly, whether that temperature range is measured, who is going to tell me? BMS and IoT will tell me. Tell me means tell the building manager that it is not working properly, either maintenance is required or such change in the settings is required. So now you can understand how building management system as well as IoT plays an important role, not only in normal life, but also in COVID scenario. Again, I have shown you the same cross section. You can understand little more better. More detailed diagram with the sensors and dampers and all those things. So this is the screen, how it looks like. This is the screen, how it looks like, and right top or right second top, you can see red color bulbs are glowing. That means it is giving some signal that air handling unit needs some change of setting or something. This is the software in the laptop or PC of the building manager. Field devices are sensors and switches. The sensors are temperature sensors, pressure sensors, humidity sensors. I told you, carbon dioxide sensors, BTU meter, level sensor, airflow measurement stations, differential pressure switch, and level switch. Now, this second one, pressure sensor, it is actually the filter sensor. So if the fan is having more pressure drop during suction, then this sensor will indicate that the filter is clogged through BMS and through IoT. Similarly, all other sensors are directly synchronized with the BMS and IoT. Cabling part, signal cable, power cable, communication cable, I'm not going into much detail. Challenges in building operation in today's life. Expectation and requirements are very different. Scale is pretty huge. Owner wants centralized operation and management at anywhere. So facility manager, energy manager, building tenant, building occupant, building owner, maintenance personnel, all the team can control and see and change the settings with the help of IoT. Home automation evolution, past, present, and future. Very interesting to know that smart home has already started. Now it will go to connected homes through internet, and finally it will become ubiquitous home, that is ambient intelligence, internet, and home automation. And the target year is around 2025. We see data analytics, a very good job market of data analytics. Everybody is learning Python and data analytics. The best part is even this building management system or MEP system are having this building management system is having data analytics required. So all the data collected from the owners, collected from the tenants, the system will accumulate and will give the building manager for future reference, so that analyzing the data, they can rework on the energy consumption, on the water consumption, and so on, so that they can find out where they can save more cost. Directly coming to a case study, this is a Bagmanek Arena, Bangalore Tech Park. Here we have already installed one building management system. So this case study I will just go through very quickly within 5 minutes. So this is the screen, how it looks like. You can see there is one left is west wing and right is right wing, east wing. So there are chillers, chiller pumps. Please try to see in the slide the gray color headings. So what all this building management system is looking like, and the same screen through IoT will be available in the mobile also. Or if you can log in to this particular software through internet from anywhere through the laptop. So we can see chillers, we can see chiller pumps, we can see transformer details, diesel generator details, and so on. Now coming to each and every case, what all data will be given by the BMS and IoT. I'm again telling, wherever I'm telling BMS or IBMS, it means BMS plus IoT, because whatever you are seeing in the PC, in that office, project office, the same thing is available with the help of IoT across the globe. So you can control, reset, analyze, make decision from anywhere. So all the diesel generator parameters are given here. So the building energy manager can check and take decision. This is the basement car parking area. So you can see there are jet fans, which there are jet fans in the car parking area because of safety, because when the car is starting, it emits carbon monoxide, which is hazardous for us. So time to time, this carbon dioxide and carbon monoxide gas has to be exhausted from the basement parking, because the air does not flow. The ventilation is very poor in basement car parking. So all these car parking ventilation fans are also connected to BMS and to IoT. Even the carbon monoxide and carbon dioxide level is measured and indicated in the BMS and IoT system. This is the sewage treatment plant, STP, sewage treatment plant. That is, now we are talking about green buildings, zero energy buildings. That means we are using, reusing and reusing the water. First, the water is for potable, that is drinking water. Second is for hand wash or taking bath. Third, the same hand wash water is used for flush water. And finally, this flush water is again treated and used for gardening purpose. So one water you are using for 3 to 4 times. So that is where the STP, sewage treatment plant, important lies. And in Salt Lake, most of the green buildings are already using this kind of systems. I am taking the case study of a Bangalore project because I am in Bangalore presently. But all the Salt Lake big buildings like Infinity Benchmark and all, they are also having the same type of softwares. This is the West Wing chilled water pumping systems. Not going into much details because these are related to mechanical engineering. These are energy meter readings, as I told you, KFC and Reebok showroom and Titan showroom, all the different showrooms, they are having their own flow rate, they are having their own chilled water flow, energy requirement, water requirement. So all these things individually are calculated. Through IBMS and IoT, it is informed to the building manager. Exhaust fans, again that AHU scenario, this is how the screen looks like through IoT or directly in the IBMS system. This is the AHU summary. You can see through the IoT system in your mobile. So these are the building performance management system. I'm just going through the slides. Now coming to the energy dashboard. You can see the various month-wise, day-wise energies are given, and those data are important for future analysis so that we can reduce the consumption. More detailed analysis, low tension energy line analysis, hourly analysis of load. So you can see, means a building management system means how much data it can give you with the help of IoT. Sitting at home, you can have all the data. I'm just scrolling through the slides just to give you idea, not going into detail. So finally, we come to an end. I hope you enjoyed my session, though you people are from information science and computer science background. I tried as much as possible to relate the industry or commercial applications with building management system through IoT. So, sir, any questions?
Thank you so much, sir. Thank you to enrich us with your valuable lecture, and we are really happy that you have bridged the current pandemic situation with the IoT. This is really a great lecture we have today.
Thank you.
So we will have a question answer session now.
Yeah.
So Papia Mondal, are you there? Or I can read your question?
Yeah, better, ma'am, you can read the questions. I will read the answers. Hello. Hello.
Actually, I got disconnected.
No
Sorry for the inconvenience. Okay. So there's a question from Papia Mondal. Are all of this system working with the help of IBMS and IoT?
In today's scenario, yes. In today's scenario, yes. If you go back 5 years, if you go back 5 years, then all systems are not in IoT. But nowadays, whatever projects are coming, the consultants are giving the specifications with IoT only.
Okay. I hope, Papia, you got your answer. Sir, another question is from Mr. Praveen Kumar.
Yeah.
In terms of frequency of maintenance and cost of maintenance, which is better, IoT, BMS, or traditional BMS?
No, that's what I showed in the slide. No, traditional BMS is always costlier.
Okay.
Means it is a question like just before Geo came and after Geo came. Are you getting me? You think of that Hutch and Commander mobile service. It was around 10 rupees per 1 hour, 1 minute, whereas Geo gave it for free. So it is like that. So IoT platform is definitely, yes, little initial investment will be little more, but in the long run, the running cost will be negligible.
Sir, if it is possible for you to switch on your webcam so that our participant can see you during the session. If it is possible, then sir, please switch on it.
No, I am not actually that handsome. Anyway.
Oh, okay. Okay. No, sir, you are.
Am I visible now?
Yes, you are visible.
Okay.
Okay. Any more question from the audience? You can ask.
Dr. Odhikari, I would like to ask you one question. That is, you said about BACnet, the things. The things must be window based so that you can have internets of them. Is
No,
that have I got it?
I gave Windows example so that I heard there. You can understand the analogy of backnet like Windows. Backnet is a platform where all the other applications are synchronized. Am I clear, sir?
So essentially, if if some manufacturer develops his gadgets around Linux, and if some other manufacturer manufactures gadgets for based on Windows, they can still be participating, cooperating and integrating in IBMS.
That's correct, sir. Actually, the consultant when designing the building will mention the components should be backnet compatible.
Okay. Okay.
I hope I'm clear, sir.
Okay. Yes. Thank you. Fine. That was my.
Okay, sir. So there is one more question from Sudipta Paul. I couldn't understand the analogy between an OS and BAC net. Kindly explain a bit to me.
Okay. See, what I am trying to tell is you bought a laptop and it is a Windows laptop. Now, after bringing the Windows laptop, it is only having operating system, no application software. Then you have to install separately the Microsoft Office, the VLC media player, the Winamp media player, the Photoshop, Adobe Photoshop. So for various application, for various requirement, one by one, you are installing various application software in that laptop. But all the laptops should be Windows compatible. I hope I'm clear. Similarly, when I am talking about BMS or backnet, there will be a DG set software. There will be a chiller software. There will be a pump running software. So all these softwares should be backnet compatible. I hope I am clear.
I hope it is clear to Mr. Sudipta Paul. So one last question from Rajushri Banerjee. How to optimize the task of inspection in buildings?
The question itself is the webinar. when you are having a building management system and that too connected with IoT, optimizing means not minimizing, not maximizing. So optimizing is done by the building management software itself. For example, shopping mall, 11 o'clock in the morning, very less crowd. Basically, there is no crowd, only the shopkeepers are there. The chiller will be given information or feedback that please don't produce much cooling. I don't need much cooling in the central mall space. So the chiller will start operating at a lower capacity. Evening 6 o'clock, the feedback will go to the chiller. It is maximum capacity, please run in full speed. So the chiller will start operating at a full capacity speed. 10 o'clock, there are few movie shows, 10 o'clock, 12 o'clock at night, very less crowd. Shops are open. In the feedback sensor will give a feedback, chiller, please run at a lower speed. I don't need that level of cooling. So this is what is optimization. So BMS, integrated building management system, will help the entire project. I'm not talking about a particular thing, entire project, whether it is chiller for air conditioner, whether it is DG set, whether it is fire pump, whether it is pump, whether it is elevator, everything will be controlled optimally. If it is required, it will go. If it is not required, it will stop. I hope I am clear.
I hope, Mr. Rajeshri Banerjee, you got your answer. Um, okay. Thank you so much, sir. Dr. Odhikar, we really enjoyed your session. It was a very wonderful session. The way you have explained, the way you have bridged the pandemic situation with the IoT, we really enjoyed it. Thank you so much, sir. Once again, a
And
huge
thank you, ma'am.
thanks
Thank
to
you all the organizers of FDP webinar who gave me the chance to talk as a speaker in this FDP. Thank you, Bibi Poddar.
Thank you so much,
Stay
sir.
happy,
Thank
stay
you.
safe.
Yes, sir. Sir, you too. Thank you, sir. Uh, Now moving forward to our next session. Now I request Lipi ma'am to please continue the session forward. Lipi ma'am, please.
Thank you, Shudipta. We will move forward to our next session. In this session, actually this is a hands-on session. We have Ashim Kumar Panda as the speaker. We have already introduced Mr. Ashim Kumar Panda in yesterday's hands-on session. So without wasting any time, I'd like to request Mr. Ashim Kumar Panda to take the charge of this session.
Okay, thank you, Lividi, for the introduction, and good afternoon to all the participants. So today, this is the second hands-on session, and I will start from the Arduino IDEO part. So let's go to the presentation first, then I will move to the hands-on session. Okay, so the theme of the hands-on session is anybody can develop an IoT application. So now it is clear to all that why we have to choose IoT, because from industry point of view, obviously it is very much beneficial for the companies, but at the same time, I think from individual point of view, it is also very much important. Okay, participants, am I audible? Sound is clear?
Yes, please.
Okay, okay. So from the individual point of view, it is also very much important for us to develop IoT applications. And yesterday, I have talked about the IR sensor based LED bulb, and that is also available at my washroom actually, because due to the problem that often at night we forget to switch on the light and switch off the light. Not switch on, basically switch off, and that will cost us dear. So as the electricity unit is too much, obviously in all over the country, so that's the reason we should automate some activities where the IoT device can help us, like staircase light, common area light, where it is essential to switch on the light at the time of evening, because at that time maybe elderly people or other, not elderly actually, for all of us, the light is essential. That means if we can automate the bulb whenever there is a less light, okay, or the light intensity is less, so that automatically the bulb will be on, and during morning automatically it will be off, so we don't have to manually operate it. Okay, so let's move to the second application of the hands-on session, and that is automatic LED bulb, obviously depending on the environment light. So today at first I will discuss the contents. Okay, so what are the contents for today's session? So first I will discuss Arduino IDE setup. After that, automatic street light, or not street light, maybe any light, okay, and that will turn on and off depending on the environment light. After that, introduction to DHT11 sensor, and again DHT11 sensor connectivity with the Node MCU, as we are working with the Node MCU. And after that, Node MCU web server, and introduction to MIT App Inventor 2, and at last but not the least, Android app development. I think that is the most important part, because without smartphone app, nothing is smart, right? So we all are using smartphone. That means we are smart people. So how IoT can be smart without using an Android app? Not only Android, but also iOS or maybe Windows. Okay, so we have to do that also. Without application, there is no value in IoT device, I think, right? So joking about, so move to the next slide. Okay, installation of Arduino IDE. Okay, I think for the advanced learner who already know that how to install Arduino IDE, for them maybe it is very basic, but my aim is that the beginners, okay, who want to start their IoT journey, so it's for them. Actually, the installation of Arduino IDE and the setup with the Node MCU a little bit critical. In my view, actually, you have to set up the port and other drivers, libraries. So various technical parameters are there. So for the beginners, I think some introduction will help. So that's why I will just one quick recap. I will give you a quick recap of how to install the Arduino IDE. So step one, obviously, you should have the Arduino board. In my case, I have a Arduino Node MCU, and obviously you have to download the Arduino IDE. Then just power up board. That means it may be through USB cable or USB charger, and then launch the Arduino IDE. Then obviously, yeah. Okay. Sorry for the inconvenience. I think right now it is visible. Is it so?
No, still it is not visible.
Okay.
Okay, now it is visible.
Now it is visible. Okay.
Yes.
Okay, fine. Okay, I think right now it is okay for all of you. You can.
Yes.
Okay, visualize this.
Okay now.
Okay, fine. So this is the installation of Arduino IDE actually. Okay, so these are the steps I already described to you. Okay, so just go through these quick points and it will help to set up the Arduino IDE. Okay, and first, obviously, you have to just use a Arduino board. It may be Raspberry Pi, it may be Arduino board, or it may be Node MCU. So you can choose it depending on your requirements, depending on your problem. You can choose any of the board. After that, you have to download the Arduino IDE, and then obviously you have to power up. You may use USB charger, or maybe you can connect with the laptop or desktop or any computing system that will provide you the power. Next, we have to launch the Arduino IDE. Next, obviously, we have to do with the fast project. So these are the things we will explore in Arduino IDE also. Okay, so first let us go to the Arduino IDE software, and then I think it will be clear to all of you that how to use it. Okay, so right now what I will do, I'll go to the Arduino IDE. Okay, so wait a minute, I will just switch it on the Arduino IDE. Okay, I think that right now the Arduino IDE is visible to all of you. Is it? Okay, fine. So there is a code actually. So right now, don't focus, don't concentrate on the code. Right now, I will explain how to use the Arduino IDE. So this is the interface actually we have. And first of all, what we have to do, we have to initialize the board. Right now, I am using Node MCU. So first thing what we have to do, we have to go to the preference option. Okay, and here for the beginning, this field will be empty. Just you have to put this URL link here. Okay, so from this URL, actually it will download all the libraries. Those are essential for Node MCU. Okay, so at the beginning you have to put this URL link in the Arduino IDE so that it can fetch all the required files from the net. Okay, so this is the thing first you have to do in Arduino IDE before using it. So in my case, it is already available. And after that, you can write down the code here. Okay, and next what we will do, actually we will go to the sketch option. Okay, and here you can compile the code, upload the code to the Node MCU board or any board, whatever board you are using. And before that, one thing you have to include, that is include library. Okay, so you have to manage this one. So I will go to this one, and I will install the required library files. Those are essential for the system. Okay, so in my case, we have to download the ESP8266 library so that we can use the Wi-Fi capability of Node MCU. Right, so that is the thing. And how to search for that particular file? Here we'll search for that ESP8266, and obviously it will give you the desired file if it is available in the system. Okay, so lots of libraries are available right now, and we have to choose, like ESP32 is here right now, and okay, this is ESP8266 HTTP. So it depends on your project, what kind of library files you require for your project, and after that you have to download and install that library files. Otherwise it will not work. Okay, so this is another, that means these files are developed by different vendors. Okay, and depending on the requirement you have to choose that one. So that is the activity we have to do before using the Node MCU board. After that we have to go to the tool option, and again we have to choose the board. So again it is available here. Okay, as we already have the library files with us. Okay, so that's why this file is available us. So let's choose the board. Actually you can explore the boards. Okay, so then the upload speed, baud rate, CPU frequency, so all the technical parameters are available, and the most important is the port through which the Node MCU will communicate with the computer system. Okay, or Android Arduino IDE. Okay, so this is the vital parameter we have to look for. Okay, so this is the I think a preliminary introduction to the Arduino IDE, and after this preliminary introduction, what I will do, I will run a code in my Node MCU. Okay, so right now this is the code. Actually I am using here one LDR sensor. Okay, so one LDR sensor I am using here, and these are the parameters actually. So LED pin 5, that means GPIO 5. So I am connecting the LED pin to GPIO pin 5, and it will be D1 for Node MCU board, and the LDR pin or the LDR sensor input will be connected to the A0 pin. So remember, this is the one and only analog pin that is available in Node MCU. So if your sensor will provide analog output, so you have to use this A0. So you can say this is one of the drawback. Actually I will not say drawback, because if you have multiple inputs for analog, then you can't use, then you have to use any other means. Okay, but most of the time we don't require that. So one analog pin is available in Node MCU, and in case of LDR sensor we can use that analog pin, and that is A0 here. So I have used that one, and the beginning the value will be 0. Obviously I have initialized it with 0, and after that in the void setup function, okay, I will write the first one, serial.begin. Actually in Arduino IDE we have one serial monitor. Okay, so to communicate with the serial monitor we have to use this function. Okay, and this is the baud rate actually. So this is the rate through which the Node MCU will communicate with the serial monitor. After that pin mode, LED pin and output, so it will define actually LED as output. Okay, LED pin as output, and then LDR pin as input. So these two things will define the input as well as the output. Okay, next what we will do, we will just read the value through the analog read function from the LDR pin, as we already mentioned LDR pin as input. So this is the input, so we will use that variable LDR pin here. Fine. Next some condition is there, depending on that the bulb will be on. So we have to put some logic actually. Okay, so depending on the sensor value and depending on the light, obviously the sensor value will vary. So depending on that, we will just drive our bulb, whether it will be on or off. Okay, so before that, it will use the serial.println, and actually it will print the value in just serial monitor. So here you will have the output actually. So it's like a screen for normal C programming or any programming where you can print the value, or you can print any welcome message or anything. Okay, so after that I am using one leap logic. So I want to say one thing in Arduino IDE. Actually, basically we will use the C language, C and C++. Okay, actually we are very much familiar with C, so I think it is better for the programmers, or maybe for anyone actually. If you are comfortable in C, then use C, otherwise C++. So all the here syntax and semantics are as C. Okay, the same as C. So we will use that syntax actually, and I am using one if condition here. So if the LDR value greater than 300, automatically the bulb will be in on mode. Okay, then we will write the LED pin high. So the LED bulb, the pin will be in high mode, and automatically the bulb will on. That means it will drive the relay. Okay, and make the circuit close, and that will help the bulb to switch on. Okay, next we will print that one value, and these are the just syntax to print the value. And obviously in else part, obviously it will low, otherwise if the condition is not satisfied, so obviously it will be low. And in the control monitor or serial monitor, we will have LEDs off. So here I am giving a delay of 7 seconds. Okay, so you can choose as per your own requirements. So depending on your environment, depending on your requirements, you have to choose the delay. So there is no hard and fast criteria that you have to choose that as per the specified one. So right now what I will do, I will close this one, and I will go to the demonstration part. So right now I will stop the presentation part, and I will move to the webcam part, so that you can view the demonstration. Okay, so wait for 1 minute. So right now I think one video is visible to all of you. Please give me response if the video is available to you or not.
Yes, sir.
Yes, sir.
Okay, fine. So I will zoom in a little bit more, so to point out that how the LED bulb will behave depending on the LED sensor. So just okay. So right now I think you can view that there are two sensors. Okay, one is DST11 sensor, all of you know, and another one is LDS sensor. So here the LED bulb will work on the principle of LDR sensor. So wait. Okay. Now this is the LDR sensor actually. Okay. Now depending on the value we will have through the LDR sensor, the bulb will be on and off. So let's check it out. So what I will do, I will block the LDR sensor. Okay, so you can visualize the. Okay, so right now you can see that the LED bulb is on. Okay, so there is obstacle, that means it can't face the light. Okay, from the environment. So obviously it will sense that the environment is dark. So automatically it will switch on the bulb, because the LDR value is here more than 300. Okay, so automatically it will switch on. Again, I will do that same event again. So in front of the diode, I will put my finger. Again, what will happen? Again, it will switch on the bulb. Okay, so I think right now it is clear to all, and why it is and obviously the delay factor, as I already said to you that there is a delay of 7 seconds, so that's why it will turn on for 7 seconds. But for our environment, like for street light, or maybe for our normal common space light or staircase light, not staircase. If we require to it switch the bulb, maybe switch on for the internet. Okay, then you should just arrange that one. Okay, you should change the delay as per your own requirements actually, or you can't. You may omit it also. Okay, so this is the now I have one of this at my common space, because every time we don't have to switch it on and off manually. So at my home, actually, I'm trying to use some smart bulb. I think till now it is not smart enough. Okay, so we will discuss about smart bulbs. So in the next session, maybe we will demonstrate some of the smart activity the IoT can do. Okay, so till now this device is okay, I think, right? So for this we don't require any kind of internet activity or connectivity. Okay, so you may say that sir, we are talking about too much for Node MCU because it has the Wi-Fi capability. But till now there is no such activity where we are using the Wi-Fi capability. Then what is the necessity? Okay, why is we are giving so much importance to Node MCU? Because for these two applications, actually we don't require any connectivity, because it can serve the purpose without any kind of interference from us. Where we need connectivity, yeah, one thing we can do that yes, we can fetch the information, okay, whether the light is on or off, or is there any problem like that. But typically saying we don't require as such. Okay, so this is the feed camera feed actually I am getting from my IP camera. Okay, and these two sensors I think you can visualize. Okay, so right now what I will do, I will again go back to my presentation. Okay, and then I think, okay, I think the presentation is visible to all of you. Is it visible? Presentation is visible to all of you?
Yes, sir. Circuit board.
Yes, sir.
Okay. The camera is only visible, right?
Yes, sir.
Okay. So wait a minute. Okay, so right now I think it is visible. Okay, so let's play a video and okay, just watch the video. So the video is actually available in YouTube and it is developed by Sukan Corporation. Okay, so just watch the video. Okay, sorry. I think right now it is the audio is audible. Okay. Okay. Thank you for watching the video. So again, coming back to the presentation, and as you already noticed that there are two sensors available in my NodeMCU board. Actually, both the sensors are connected, and one of them is the DHT11 sensor. So first of all, I will explore the DHT11 sensor. Okay. Now, what DHT11 sensor actually will do? It's a humidity and temperature sensor actually. So it will measure the humidity and temperature from the environment. Okay. So in this sensor, actually there are 3 pins. Actually there are variants available for DHT11 sensor. Okay, there is DHT21, DHT22. So in my case, in the DHT11 sensor, I have 3 pins only. Okay, and if you have 4 pins DHT11 sensor, no problem. The NC or this pin is not actually not working actually. That means you don't have to do any activity with this pin. Okay, there is no utility with the NC pin. So this is the NC pin actually. Okay, now let's check out other pins. One is VCC. So we have to connect the VCC with the VIN or any 3-volt power source of the NodeMCU. Okay, so here the pin is connected with the VIN. Okay, and next data out. So through this pin actually the DHT11 sensor will transfer the data, okay, from the environment to the NodeMCU board. So that is critical. So you have to define that pin actually in NodeMCU, what pin you want to use. Okay, and here it is connected to the D3 or GPIO pin. GPIO means general purpose input output. So actually you have to remember the pin diagram of NodeMCU and the mapping also with normal Arduino pin diagram, right? So there is a little bit of mismatch with the normal GPIO pin. So these two are not same. So D3 and GPIO 3 both are not same. So we have to remember that mapping. So actually here the data out pin is connected to the node MCU D3 pin, okay, or GPIO 0. Again, there is another pin, that is the ground pin, and we will connect this ground pin to the ground pin of node MCU. Okay, so this is the node MCU structure, all of you know, and so this is the circuit configuration actually we require for collecting data from the environment, okay, using the DHT11 sensor. Okay, so I think right now, okay, fine. So right now I will move to the Arduino IDE so that we will run the code using DHT11 sensor, and we will fetch the data from the environment. So let's check out if DHT11 is capable of getting the data from the environment or not. So that's why I will switch on my presentation to the Arduino IDE. Okay, so right now I think the Arduino IDE is visible to all of you. So what I will do, so I will open the DHT11 code. So this is the DHT11 sensor code that I will run. Yes. Actually, I will try it out, okay, but I don't know if it is properly visible or not. Okay, so I will try. So right now, can you, okay, before that, I will try to zoom it out. I think, okay, later I will explain the code actually, okay. in maybe in tomorrow's session. So I will try to paste the code in my presentation so that you can view the code properly. Okay, but I think from this Arduino IDE interface, I think it is not possible to zoom in. So sorry for the inconvenience. And tomorrow I will just show you the code line by line so that it can be visible to all of you. So right now, DHT11 sensor code is available in my Arduino IDE. So I will run this code to my Node MCU board so that I can get the humidity and temperature data from the environment. So let's run that code in my Node MCU. So it will take a couple of seconds to upload the code in Node MCU, and after that we can get the data from our serial monitor. So for that, again, I have to just switch the tab to the serial monitor so that we can visualize what are the data those are available from the environment. So okay, so right now I think it is available, and we have successfully uploaded the code in Node MCU. So just wait for a second. I think right now the serial monitor is visible to all of you. Is it visible? Is it visible?
Visible.
Yes, right. So, yes, sir. So right now you can visualize the data actually. So right now the current humidity is 81% and the temperature is 34.1. Okay, so this is the serial monitor where we can have the data. Okay, and right now I am getting the data from my DHT11 sensor. Okay, and these are the data of the previous application, actually the LED LDR sensor data actually. Okay, so right now the DHT11 sensor is taking the data from the environment, and okay, actually there is a delay of I think maybe 5 seconds or 10 seconds. So the data will come after the delay of 5 seconds or 10 seconds. You can again customize the delay because it is not required to fetch the data. I think in case of temperature and humidity, we can have a delay. Okay, maybe after 5 minutes or 10 minutes. So whatever suits your requirement. Fine. So this is the DHT11 sensor data we can have through the Node MCU. So till now we have two applications, one with the LDR sensor and another one with the DHT11 sensor. Okay, fine. So I want to show you another software actually that is capable of getting the serial monitor data. Okay, so right now in Arduino IDE there is only one tool that is available with us, that is the serial monitor to fetch the data from the Arduino IDE. Okay, otherwise you will transfer the data to any cloud platform. Okay, then it is also possible. Obviously, if we connect our Node MCU board to any cloud platform, then we can visualize the data on that platform. So that is possible. That's why the Wi-Fi capability is very much important in case of Node MCU, and we don't have to put extra peripherals. Okay, with the Node MCU, it is capable enough to transmit the data with the help of TCP/IP protocol, or maybe you can use the IoT special MQTT protocol. Okay, so depending on you, you can use both, but the TCP/IP will be a little bit heavy compared to the MQTT. Okay, so these are the outputs we are getting, and so till now we don't require any activity. Activity means we don't require any kind of network connectivity, right? All the applications are self-dependent. In one case, we can say self-dependent. Okay, they are not dependent on cloud or internet. Fine, but if we concentrate on this humidity and temperature data, so what is the purpose? Why we want to fetch this data from the environment, temperature and humidity? What it will serve? Actually, right now at my home, I have two smart devices. Right, one is my smart bulb at my washroom, another one smart bulb at my common space. Okay, so typically I face a common problem with my AC actually, or air condition. Actually, I can't utilize it all. That means I want to minimize the power consumption. Like during the night, we should increase the AC temperature because say at 2 a.m. or 3 a.m. It is not required to put the temperature in AC at 25 degrees Celsius. Maybe at that time we can increase to the 28, right, or 29. Or maybe at the morning, if the condition or humidity is less. Okay, if humidity is high, then obviously we have to use the dry mode, right? If the humidity is less and the temperature is also less, why not we will switch off our AC and turn on the fan? So it will save the energy also, and it will be beneficial for us also. Again, how to change the mode? Once you are in the sleep mode, you can't control the remote. Maybe whatever customization is available in your remote, but you can't do it fully. Okay, so if the humidity is suppose 95% or 90%, above 90%, so at that moment I think if we'll switch the AC mode to dry mode, it will be best for us. Okay, or maybe in case temperature is too high, say near about 40 degrees Celsius, so at that moment I think the cool mode is better, that will suit our environment and room temperature also, and that will give us the comfort at the same time that can minimize the energy consumption. So because ACs are one of the most energy hungry device at our home, so if we can minimize or if we can utilize that device, that means we can control the power consumption, right? Because nowadays almost everybody has ACs, right? Not one, maybe more than one. So in each room we have one AC, and that will give us the more pain actually in terms of money. So why not we will have one smart AC control system that will control my AC at the same time my fan also, so that depending on the environment we can switch it on and switch it off, or maybe it will change the mode. So that is my next target. Maybe I am unable to, I can't show you the demonstration of that smart AC because it is going on. So right now I don't have the full system. So better right now what we will do, we will go to the connectivity part. Okay, so right now I will close the serial monitor actually. Okay, so right now it is clear to all how to get the data in serial monitor, how to burn the code in our Node MCU board. Okay, so for this kind of application I think you can easily develop, and there is no complex terms, right? Easily simple C codes are available, and just you have to define the pin, okay, input pin, output pin, and then you can just use some proper syntax for Arduino IDE, and then hit the go button. Okay, you are ready to fire, and you have your first IoT enable, or I will say device, smart device that will work on certain logic. Okay, so let's close the serial monitor here, and I will switch on my actually. Okay, next what we have to show, we have to show the connectivity part, right? So better again, I think I have to go to the Arduino IDE so that I can show you one of the connectivity part. Okay, better. So so again I will go to the Arduino IDE. So I don't know if it is properly visible or not. So don't worry, tomorrow I will have the code in my presentation so that it will be properly visible to all of you. Okay, because I am unable to show you the code in that means in zoom mode, so that it will be properly visible. And okay, so this is the code through which I will connect my LED actually to the network. So right now, what is my purpose actually? I want to control my LED. That means I want to switch on or off Okay, not it is actually it is not dependent. Okay, it is not independent actually. It will be dependent on my input. Okay, so whenever I like to switch on the bulb, it will be on, and when we like to off, it will be off. Okay, so it's not totally automatic. Okay, so it will depend on the user input, whatever user like. Okay, so for that purpose, what I have to do, I have to control the node MCU. So here the Wi-Fi capability will play a vital role. Okay, so this is the code actually I have, and this code I will run in my node MCU, and I think that will give you the proper insight how we can communicate with the node MCU, how the internet will play a big role in connecting all the devices and communicating with the devices through obviously human input. And so now for this code, what do we need? We need one extra header file. Okay, so in the previous codes we don't require any extra header files actually, but here we need this one, ESP8266 Wi-Fi.h. So this header file will do all the connectivity related activity. So that's why we have to put this header file in our coding right now. Then what we will do, actually we have to connect to our Wi-Fi Wi-Fi router actually. Okay, so this is the SSID, that means your Wi-Fi connection name. After that, the password. Through that, it will connect to your Wi-Fi. Okay, after that, I have just defined GPI of 5, and it will be equivalent to D0 of node MCU. Okay, so I will connect that pin, okay, for controlling the LED. After that, it will start the Wi-Fi server. So 88 is the port. So at 80, it will connect. Okay, actually we are using HTTP protocol, so the 80 is the normal port that is defined for that purpose. Again, in the void setup function, we will use the serial.begin function so that we can communicate with our serial monitor. After that, we will define the LED. Okay, that is already defined for pin 5 as output, and we will do other digital write functions also. Okay, so next, these are the functions through which we will begin the Wi-Fi. That means Wi-Fi.begin. It will connect the node MCU with the Wi-Fi router. Okay, so if it is connected, then it will print some dot, and after that serial.println, then it will show you the message that okay, Wi-Fi connected. Again, we will start the server.begin. Using this we will start the server. Okay, so again after this it will show you server started. Fine, so this is the code actually we have. So right now I think all of you are more interested to view the demo, I think. Okay, so yeah, obviously the code is vital, and but right now I think it is, I don't know how the code is visible to you or not. So better I will run the code in my node MCU. After that we will watch the demo. Okay, so better I will just run the code in my node MCU. So wait for some time, and after that we will have our node MCU ready for the project. So what I will do, I will upload the code. Okay, so let's run the code. So it will take some time, maybe a couple of seconds to complete the entire procedure. So so right now what we will do, okay, I have to stop the presentation, and then I have to just move to the Arduino serial monitor, because otherwise you can't see the output. So right now it is okay, and it is the code is successfully uploaded in my node MCU, and right now I can utilize the node MCU. Okay, so the purpose of this application is to control the LED, okay, through my smartphone maybe. I don't know if we can control it through our smartphone, but obviously we can control through internet. So here again, I am saying another important factor. It is not necessary to have internet, okay, for IoT devices, because if you don't want to control the device from outside world due to security reason, suppose you have a one Wi-Fi or IP camera, okay, and you are connected to the internet. So maybe from the outside world, anybody can hack your camera. That is possible. But if you are using the camera at your home with your intranet, okay, only LAN, then it is not possible for outside person to access to your camera or other security devices. So if you don't want outside access, or if you don't want to monitor your home or other activity from outside world, it is not required. The internet is not required at all. So we can have all the activity using intranet also. So two types of application we can develop, one using the intranet, another one using the internet. So right now I will show you the application that will run on intranet, not internet, okay. So maybe tomorrow we will have the internet based applications, okay. So but right now we will move step by step. So the first step we will have regarding the connectivity, we will just use the internet fetcher, okay. So let's move to the, so right now I will close the serial monitor because right now I don't require it, but okay, I require the serial monitor actually. So let's have the serial monitor. Okay, so I have to switch it on. Okay, control monitor, yes. I think right now all of you can visualize the serial monitor actually. I don't know if it is visible to you or not. Is it visible? Okay, okay. Okay, so right now some notifications are coming in my serial monitor. Okay, so yeah, the node MCU is connected to my Wi-Fi network actually, and the Wi-Fi router allocated one IP for this node MCU, and that is 192.168.0.103. So you can easily get the idea that this is entirely an internet address. Unless your router has the internet capability. Okay, if your router don't have the internet capability, then it is purely internet. Okay, so better if you wish to have internet connectivity, you can go with that. Otherwise, internet is fine. So right now we will use this IP for controlling our LED. So what we will do, we will use this one, the IP. Okay, so let's copy the IP address, and again what we have to do, actually again we have to stop the serial monitor, otherwise you can't view the demonstration. Okay, so let's stop the presentation again, and okay, so we will have a new tab, or maybe yeah. So wait for a few minutes. So okay, new window, and So better I will go to the new tab so that you can visualize the data. Okay, so actually in Chrome I have some security issues, so better I will focus my camera to the Mozilla browser so that we can have the browser activity, how we can control the LED. So I will switch on my camera actually to show you the demonstration. I think right now one browser is visible to all of you. Is it visible? Okay, so right now you can see that the LED status is off. So right now I can't show you the camera feedback, camera view actually, because right now I am concentrating on the browser. Otherwise, it will be best to show you both the stream. But okay, let us concentrate on the browser first. So right now you can see that two options are there, and the current status of the LED is off. Okay, 2 button is there. So whenever I will switch, just click on the button on. Okay, so automatically okay, so let's have a quick look on the valve. Yes, it is on. So you can visualize it. Okay, so it is not possible to show you the simultaneous view, but yeah, I can give you the view one by one. So right now it is on. So you can see that yeah, we can control the LED bulb from our browser also. That means from our computer device or any device that is capable to use the browser. So what next I will do, I will just click on off. Okay, so now I will show you the LED bulb. So right now it is in on mode, right? Okay, so yes, using this code, if we run this code in our node MCU, we can easily access the bulb from anywhere, okay, from our home. So that is possible. So it is not for only one device. If you want to use this link, this IP address from other device also, you can also access the bulb. And it is not like that they are not synced. Okay, they will be in proper sync. So right now if it is off and you are turning it on, so in other device also it will show you on. Okay, so it's not like that the status will be not updated and maybe some mismanagement will be there. Okay, so there will be proper sync and you can control it from any device. Okay, so you can control it from any device. So that is the thing. Fine. So I think right now it is clear. So yeah, so we can control the, I think right now, yeah, I can show you the URL also. I think it is properly visible to all of you. Okay, so it's clearly saying 192.168.0.103. Okay, fine. And this is the option. Okay, fine. So this is fine, right? So here comes the utility of Node MCU Wi-Fi capability. Fine. Then maybe someone will say that without app, I think nowadays nothing. It's nothing. That means it's not complete actually. So we are smart enough, and obviously during night it is not possible to use our computer. Suppose I want to switch on my bedroom light, okay, or switch on my bedroom light, maybe, or maybe a common room light, or maybe anything. Okay, so at that time, obviously I will not go to my computer and use my browser, right? So it is best to develop an application. Okay, so it is best to develop an application, Android app, maybe iOS app, maybe Windows app. So right now Windows, I don't know if it is popular right now nowadays, but obviously we have to develop an Android app. Okay, so again I will go back to my presentation. Okay, so yes, I coming to that point. So the internet connectivity is okay, but okay, we should have one application to control that one. So we are doing the hands-on session. So without the app development, I think it is not complete. So we should have the application development module also. Okay, So let's proceed with the video. So this is the video, just watch it.
Hi, I'm Nick.
And I'm Tiandra.
And we're students here at the Massachusetts Institute of Technology.
Since coming to college, we realized that although high school prepared us for math, English, and science, it hadn't really taught us anything about a skill that's becoming increasingly important: programming.
In fact, most middle and high schools don't offer computer science classes at all. So, a team here at MIT's Center for Mobile Learning created a tool called MIT App Inventor that allows people of all ages and all levels of coding experience to learn the basics of programming.
App Inventor features a drag-and-drop programming interface that allows anybody to create mobile apps for Android devices.
Hi, I'm Shay Pokris, and I'm the Director of Education for MIT App Inventor. Traditional programming can be kind of intimidating because people often think of, oh, it's black and white text on the screen, and I don't know what program do I want to program in, and there are all these languages, and it can be hard to get started. But App Inventor lets you get right to the logic of programming.
Oh, hey, Matt. How are you?
Hey, how's it going, Matt? Good to see you.
We're actually going to click on button 1. Button 1. Mouse. All right, it's very exciting. All right, so first you're going to...
So what you're going to do is, you're going to click button 1.
Mobile devices are everywhere. And the discovery that you can customize that for yourself is pretty remarkable.
When someone takes a picture, it says, "Congratulations, you're beautiful." And then, "Congratulations, you are beautiful." Yeah.
Should be all ready to go.
So, click. That's pretty cool, huh? Today, in our pockets, we carry around more computing power than NASA used to put a man on the moon. And now, you can harness that power using MIT App Inventor. Don't know how to get started? Click on the link below to create your first app. There are tons of tutorials that you can access across the web, made by people from all over the world.
App Inventor is free and open to all, so check it out online and begin personalizing your mobile experience. Happy inventing!
Okay, so today I will introduce the MIT App Inventor 2. So again, maybe you will ask why MIT App Inventor 2. So there are some actually motivation behind this. Okay, when I thought to develop my own IT application in Android, so at that time I was very much confused that how to develop that one and which interface I will use, which system I will use. Okay, what will be the software? So for I think one of the software is Android Studio. But for that I have to that means I should have a very good system with high capacity RAM and those things, because it's a heavy software. So I don't want to install that software actually. Okay. So at that time I thought that, okay, is there any alternative to develop something in Android without so much work? Because my purpose was not to give so much time in Android app development, because I want to do with the IoT things. Okay, so that app development was a secondary thing. Okay, so that's why I don't want to spend too much time on the Android Studio. Okay, so that's why I came to know about MIT App Inventor, and it's a very nice platform. So what I will do, just right now, I will stop my presentation and I will switch to the MIT App Inventor for creating Android app in, I think, in 5 minutes. So in 5 minutes, you can have your own Android app. So right now, what I will do, I will go to the MIT App Inventor, and then I will explain the feature also, that what are the unique feature the MIT App Inventor is capable of. Okay, so fine. This is the, okay. Right now, I think it is not better to explain the feature. After that, I will show you the coding. Okay, fine. So this is the MIT App Inventor, and it is totally internet based. So one, you can say that, yeah, you can't work in offline, obviously, because you have to connect it with the website, and using your Gmail ID or anything, any ID you can use. But it is not possible to work with the offline. Okay. But that is okay. Maybe in this app we have this constraint, but the entire app, interface is very nice to me, and it's a drag and drop application actually. Okay, so I don't have to spend too much time. So it's for those who don't want to spend too much time on Android development actually. So Android application is a part of the entire IoT package. Okay, so we should have the app. For that, I think for my purpose, it is a secondary thing. So that's why I don't want to spend too much time. So it's a drag and drop application platform. So easily we can do all the activity here. So one thing I think, okay, so today I will not discuss too much about MIT App Inventor 2. Rather, I will focus on my application, okay, through which I can control my LED bulb. So that is my purpose actually, nothing else. So what I want to do, I want to develop an IoT application, an Android application, and through that, I want to control my LED bulb. So that is the sole purpose. Okay, so what I will do here, I will just take two buttons, okay, one for on and off. Actually, the button will serve the activity purpose. Whenever you have to do some action or activity, you can use the button. So clicking on the button will initiate the activity. So here two actions are there. So obviously on and off, fine. So what I will do, I will take two buttons. That's why here button 1 and button 2, fine. And this is the screen actually. So in the left hand side, you can get all the options. Okay, using these options, you can develop your application. Okay, and in the right hand side, you can have the properties. So right now, this is the screen. Okay, screen 1. So I have the properties of screen 1, and yeah, I can change the background image, color, all those things. Right. So this is the background image. If you select any file, it will change the background image, and color is also right now it is light gray. So let's change the color. So it may be white. Okay, so it is white right now, and next. Okay, so changing to gray again. Okay, so it will change again. You can change the properties. Okay, so I will say that, okay, explore the platform and you can develop your own, no problem. So if you are interested to IoT and you want to have your own application, you don't have to depend on third-party application like Blink and other application. Okay, so you can have your own server actually. So that's my motto. I don't want to depend or deploy the data on third-party sensor. Maybe, yeah, for cloud, obviously you have to just deploy the data to third-party cloud, but those are trusted one. Okay, so here my purpose is, if you are using internet services, why I will use the third-party activity? Okay, so why not we will have internet server at our home? So that is very much easy and simple, and we can develop it. Okay, so that's why we have to develop our own application. And there is another point that we can customize it. Depending on our requirements, we can customize it. So that is the key thing. So here, these two are the buttons. Okay, then we have one web viewer and web activity. Okay, so this web activity actually for connectivity purpose, the MIT App Inventor, we have these options. So one is serial communication. That means you can connect your USB cable to your desktop or laptop and you can communicate. That is also possible, but that is not wireless actually. So obviously we will not try that one, because we need wireless communication so that we can communicate from anywhere. Okay, so we will choose this one, web connectivity, and it will use the HTTP protocol, and that will connect the application to the Node MCU. So I have used one web connectivity, and that is available here. So the web connectivity is not visible actually in this screen. There is another one, web viewer. So right now it is not required actually. Later I will describe that for what purpose I have used this web viewer one, and that is also very interesting and nice actually. Okay, later we can have this web viewer one. Okay, the purpose of web viewer one, Actually, yeah, okay, I can say that it will get the web view. If you specify the IP that from that means the source, IP source, automatically it can fetch the data. It can fetch the view. Actually, I want to fetch the data, fetch the view from a webcam. So I already have one IP camera. So I want to get the view that whether the light is on or off. Okay, so I don't have to go to other app also. Okay, using the camera feed, I can have the details whether the LED is on or off. So that's why I have included this web viewer one tool here. Okay, next what we will do, okay, go to the blocks. So this is the design part. So obviously we have to do some programming, but here we don't have to define anything like C, Java, or any other programming language. So it's a block based, right? Okay, so what we need the IP address of my node MCU, and that is already available with me, right? So that is 192.168.0.103. So this is the complete URL. Okay, so what I will do when I will click button 1, it will set wave1.url. That means it will fix the URL to the wave1, and then I will use the wave1.get. That means I will send the data to the node MCU using that one. And again, I will change the color of the button because I don't know if it is on or off. So for the status purpose, the background color will be changed. Okay, and again, it will change the background color for the second button also. That means the first button will be deactivated and the second button will be activated. So it will be easier for us to get the status that okay, right now what is the condition? Either it is on or off. Okay, so we don't know that one. And after that, we are using the web viewer one. So here we have the IP again. So we will fetch the data. We will get the view from this IP. Again, we will go to the button 2. Again, the same thing. So it is for off and it is for on. Now this is complete. So this is the thing we have to do in our MIT App Inventor, and that's it. We are ready with our first Android app for our IoT system. Okay. Now, how to connect it? How to connect with our smartphone, or how to develop the APK file? That is the key thing. So before you download the APK file, okay, let's have a quick look how to download the APK file. So first, what we will do, we will go to the build option and then this one, app provide QR code or APK. So you can have one application in your smartphone that is an MIT AI companion, and that app will connect the MIT App Inventor interface with the smartphone. So right now, if I will click on this, so what it will do, it will give you one QR code. Okay, and so okay, the progress is going on. So it will take a couple of seconds, and after that, it will provide the QR code. Okay, for the APK file, and then your first Android app for the IoT application is ready. Okay, so right now it is complete. So I think within 10 minutes or 15 minutes. Okay, so right now this is the barcode. Okay, so if you scan this one, you can have the APK file, okay, in your smartphone, and you can install it. Okay, so right now I will not scan this barcode. Instead of that, I will exclude another option. Okay, you can use either this, or you can save the APK file in your computer also, and later you can transfer the file to your smartphone. So that is also available. So right now, what I will do, instead of saving the APK file or transferring the APK file, I want to check how it looks like, okay, in my smartphone without downloading the APK file or transferring the APK file. I want to check. So how to do that? For that also, we need the MIT AI Companion. Okay, so this is the AI Companion app, the interface that is available in MIT App Inventor 2. In my smartphone also, I have downloaded the MIT AI Companion, and what I will do, so you can use the USB connection also, or just normal emulator to just look for the exact behavior of the app, how the app will look like. So all the functions are available. Okay, so what I will do, I will go to the AI Companion option. So let's go to this one. Fine, and it will go, give me the QR code. So right now what I will do, I will open my smartphone and I will scan the code so that I can have the app. So right now so two options are available. Either you can scan it or the code is also there. So right now I will use the code, and after that I can have the app in my phone. So it will take a couple of seconds actually to connect with the code. After that, we can have the application in our mobile. So it is okay. So right now you can see that yeah, it is going on. Okay, so it will take some time, and okay, so oh, yeah, right now it is, I think, done. So I will refresh the connection again. So some technical problem is there. Okay, it is disconnected. So again, I have to connect it. So let's wait for a few seconds again, and after that I think it will be okay, and then we can use the application interface in our smartphone without having the APK. Okay, so that is the thing. Okay, right now. So right now what I will do, fine, I will just use my camera that is available with me to focus on the application that is available with my smartphone. So let's switch on the camera. Okay, so right now I think all of you can visualize the screen. So is it available?
Yes, sir.
Okay. Fine. So yeah. So right now I think the entire screen is visible to all of you. Okay. Yes. So this is my LED light, and this is my app. So what I would like to do, I will just switch it on. Okay, so let's check the connectivity again, whether it is connected with the interface or not. Okay, so right now maybe the app is not properly synced with the, okay, so wait for a few minutes so that it can be synced with the interface that is available with Node MCU. So just a few seconds. After that I will check the interface again so that we can have the, okay, so it is disconnected actually with the MIT interface. So better we can download the app in our system, and okay, so let's have the app in my smartphone. After that we can control it. So basically you can control the LED bulb through this application. Okay, so better go with the application that is available through the MIT App Inventor, or rather you can use the web interface also. So some technical issue is there. I think the interface is not connected, not properly synced with the MIT App Inventor. That's why it is not working. I think all of you can visualize the programming, right? So this is the actually function block. Meanwhile, I will try to sync it properly so that we can have the app. So better if you want to download the APK file, then it will be, I think, best in case you want to show something. Okay. Otherwise, maybe the sync is a problem because we are doing the sync in wireless mode. So that is the factor actually. So maybe due to some problem, it will not work. But you can download the APK file. Okay. So you can download the APK file in your system, and you can have the application in your mobile, and then you can just connect your node NCO with the LED bulb. Okay, so yeah, so this is the entire procedure, so through which we can have a complete IoT application. Okay, so yeah, I think it is fixed. So again, I will show you the interface. Okay, I think it is fixed, and okay, fine. So let's switch on the camera actually. Yeah, so right now, yeah, the LED is on. I think all of you can visualize the LED. Okay, so this is my application actually, and that is running on my smartphone. So yes, so I will try to focus my camera on both the application and the LED. Okay, so right now it is off. Okay, so again I will try to switch it on. Yes, again I will switch it off. Okay, that's it. So now you can properly visualize that it is working. Sometimes maybe connectivity issues are there, but no problem. Ultimately, if you download the app and if you have the proper connectivity, okay. So for my own purpose, I have connected to RGB LED also, so that if we don't have the LED and relay, actually the relay is the critical part. If you don't have the relay with you, then you can't control the 240 voltage devices. Okay, because without relay it will not work, because node MCUs are not capable to drive the 240 volt, right? So the source is only for 3 to 5 volt, so not enough actually. So for that purpose, we need the relay. So if you don't have the relay, so that's why what I have done, I have just used 2 RGB LED. Okay, and that we can control that LEDs actually. So this is the overall circuit configuration, and right now I can have the app also. So using this app, what you can do, you can control the light wirelessly. Okay, so anywhere in your at your home, you can have the control. Okay, fully controlled. So right now we can say this is an complete IoT application, I think so. And that's why the node MCU is very much important for the IoT development, obviously for us actually, because cost is the matter, right? So cost is the critical factor that actually that will do actually all the things. So for today, I will stop here, and what I will do, I will go to my presentation again, and okay, wait. Okay, so these are the references, and thank you everyone for the patience and for the participation. Okay, if you have any queries, any doubts, you can ask me. Hello, am I audible? Hello.
Yes, sir.
Yes, yes, yes. So
Yes, sir. Yes, sir.
So if you have any query, any question, you can ask me.
Hello.
Yes.
Ashimda, I got some questions from the student.
Yeah.
So I'm discussing. Can you hear me?
Yes, I can hear you.
Okay. The question one student asked that 1 minute, just.
So the students can go to the link also and post your question here also. So this is the link. I think I will post it in the Gmeet chat window. Okay,
Yes,
so
yes.
you can
Okay,
have.
one there from Debraj Roy that
Okay.
what is IDR value?
Okay, idea, it's not idea actually, it's LDR. Okay, so actually it depends on the light. So the range is typically from near 0 to 10330 actually. So from 0 to 1000 actually. Okay, so that is the typical range for the LDR sensor. So for the darker side, I think it is maybe higher values. Okay, and if there is enough light in the environment, then it will be lower side. That's why I have given that 300. I think in the code I have given 300. So if it will go above 300, automatically it will be in on mode. So during dark environment, the LED will be on.
Okay, and he also asked you to send the library URL to WhatsApp group.
Okay, yeah, I will give you all the resources, and those are essential for this development. No, don't worry about this. But again, these library files actually all are available in internet, but you have to use those things. I will provide the guidelines, no problem regarding that. Okay.
Okay.
So I have a question, sir.
Yeah.
So regarding the IDR value, so you said that it requires the intervention of the users to define the IDR value. So is there a way to automate the entire IDR value which can be continuously fed to the system, that is the node MCU?
Yes, actually no human interventions are required, because you have to provide the logic actually. Depending on that logic, the node MCU will work. If you don't give the logic, then how it will work? Right? I am giving the logic that if the LDR value will be above, suppose say specific value, let's say 500 or maybe anything, then the LED will be on or off. That's it. Otherwise, no human interventions are required. Okay, it will be entirely automatic.
Okay, sir. Okay. Thank you, sir. So another thing, sir, regarding the IDR value, what if in the future I don't need actually the value? So is there a way, like you said, that IT can also be connected to the artificial intelligence, like these two go in hand? So is there a way through artificial intelligence we can actually change the IDR value actually according to the situation? Like artificial intelligence can know that now this IDR value is not required and it needs to be changed. So is there a way?
You want to just that means modify the LDR value, I think.
Yes, sir.
Okay. So yeah, obviously, actually it will fetch the value from the environment. It will sense the value from the environment. Okay. It's nothing but the resistance actually. So there is one light dependent resistor that is available with the sensor. So according to light, the resistance will vary. Okay. So that's the principle actually. So it all depends on the environment light.
Okay.
Yes.
Thank you, sir.
Okay.
Ashim sir, there is one more question from Mr. Parthupratim Shaha.
Yes.
What's the cost of developing the control circuit for automation of full house?
Full house means how many devices you want to control, that you have to mention. Okay, suppose I want to control 4 or 5 devices, that means okay, 1 relay is enough, 4 relay is enough, and it's almost 1000. Within 1000 you can develop it, no problem. Okay, maximum 1000 I am saying. 1000, or maybe if you add more sensors, maximum maybe 1500. So if you want to automate your entire home appliances, maybe entire home.
He asked know about 15 points.
15 points. Okay. Then it will cost more actually. So actually it will depend on the relay. Okay. How many relays you have to use, node MCU board and sensors. I think the cost is very less. If you want to automate from a reputed company, then the cost will be more. But at your home, if you want to develop your own application, then it is very much cheap, I think. Just node MCU cost is around 400, and if you buy from online, and if you go to your offline market, it will be less. So better go to your offline market and purchase in a bulk, and then I think the entire cost will be very less. Okay, so actually the component costs are less than 500 for all the maximum cost is for node MCU, that is 400.
Okay. One more question is there from Debraj Roy, that is it possible to simulate any code in computer without having any hardware?
No, right now it is not possible to simulate. And I don't like the simulation also in IoT case actually, because you don't have the enjoyment actually. If you simulate the IoT code, if it is available, I don't know if any simulator are available, but if it is available, then also I think the enjoyment will be more if you have the kit with you, because when your system will work, the enjoyment will give you more energy to develop further. So that is the cause for me also. When I saw my smart bulb that is available at my washroom, so that gave me more energy to develop further, and I go for the smart AC also. So that is the thing. Okay, you can, I don't know, but later I can give you the details if any simulators are available. But I think the cost is very less, and you people can go with the hardware kit also. Within 1,000 you can have a complete IoT kit. So why not? If that is available within 1,000, 2,000, then why not? We will go for that, right?
Okay.
So I have a doubt, sir.
Okay.
Sir, that's a fundamental doubt actually, sir. Is the node MCU that you're talking about, is it similar to that of a microcontroller?
Yeah, actually it's a microcontroller. MCU.
Yes,
that's
because
why
it has
MCU.
the programming capabilities.
Right. That's why node MCU, microcontrolling unit. Right?
Oh, sir.
Okay. So it's obviously a microcontroller.
Microcontroller.
Yeah.
Thank you, sir. Thank you, sir.
Okay.
Okay, so one question is from Partho Ghosh, that is, how does solar street light works?
Yeah, actually, I have given a video in my presentation. Actually, you can have a IR sensor or infrared sensor, and with that LDR sensor also. And for better result, you can have ultrasonic sensor, because most of the cases the IR sensor range is very less. Okay, so if there is a slight movement in the nearby area, it is unable to catch that movement. So better use ultrasonic sensor. Okay, so right now due to lockdown, I don't have that sensor. Otherwise, I will show you the ultrasonic sensor demonstration. But unfortunately, it is not available with me. But for this kind of application, I think you should go with the ultrasonic sensor with your LED bulb. Okay, and just connect it with your node MCU, and you can have it. So because the ultrasonic sensor will work on the principle of sound wave. So that is the difference. In case of IR sensor, it will work on infrared, but in case of ultrasonic, it will work on sound wave. Okay, so better go to ultrasonic sensor, and that is dependable also. I think. Yeah.
Yes, sir. I guess everybody got the answers. So, and thank you so much, sir.
Okay,
Today,
thank you.
Learned so many things, and we got to know so many things with a very wonderful session we have today.
I have another announcement for tomorrow's session. Actually, today we are using intranet, right? For tomorrow's session, I want to give you one hint that tomorrow we will have cloud interface. Okay, so we will send our data to cloud platform, and we will have true IoT. That means through internet we will modify, send instruction, whatever we like. So we will do those activities in tomorrow's hands-on session. So have a great day to all the participants, and thank you.
Thank you, sir. And I hope everybody got the session code, and soon you will be getting the feedback link also. So that's all for the today's session. Tomorrow we will again join around 1:45. So thank you, everybody. Enjoy your day. Good day.
Thank you, ma'am.